Alright, good day once again. I'll be introducing us to the course Physics 108, which is the experimental physics 2, and I'm by the name Olaiton Johnson from the Department of Physical Sciences. So let me just go straight into what the course entails. This is the course outline. We're going to be checking how to do a comprehensive report writing, error analysis, then the major aspect, which is the graphs, and then we'll be going into the following experiments. We'll be going through all these experiments. Let me just quickly take us through the course objectives. So as this course has been designed for students to gain practical skills in physics and to be able to experiment well simple works on it and what's it called mechanics. And at the end of this course, we should be able to write a comprehensive report, know the techniques of report writing, define errors and mention different types of errors, error measurements, estimate errors in slopes, identify the importance of graphs in the study of physics, particularly to the experiments that we'll be going through, and then you identify the variables or the physical quantities or the parameters that are measured, and then you should be able to plot a suitable graphs for any experiments that you've performed. We will actually be using a virtual lab for all of these work. But before that, let's just do an overview of how to report or writing. This is just like a summary of the experimental work, and it will actually judge the quality of our work. And it is very important for students, especially for learners like you, to know the techniques of good report writing. And what are the vital things that are entailed in a very good report writing? The first thing is the date of the experiment, which must be clearly stated. The date in which the experiment is performed, the experimental number and title, maybe experiment 1, experiment 2, and then the aims and objective of the particular experiment. Maybe let me just pick this for example, verification of Ohm's law. Yes, verification of Ohm's law. Maybe want to see the variation between the current and the resistance. Okay, do they have a linear linear relationship? And then we have the list of the apparatus. This is just the format in which the experimental report should be. We'll have the experimental dates, the title, aims and objective, apparatus that will be given. Those are the components or the devices you'll be using. But for us, we'll be going directly into the virtual lab. I think in my second video I'll be introducing us to virtual lab, how we can get familiar with some of these things, and the procedure in which the experiment was performed. Now note something: the procedure used in carrying out the experiment must be in reported speech. That is, you must avoid the use of personal pronoun, just like I did this or we did this. No, that should be avoided. So it should be written in past tense. The experimental setup was arranged according to the diagram, and the jumpers or the wires were properly connected, and the likes, in reported speech. So avoid the use of I or we, which will render your report a bit below standard. And then the diagrams for every experiment that is performed is meant to be drawn, and it should be well labeled. Don't forget, you're going to use pencil, so every drawings should be should be drawn with pencil. Then the data involved will be tabulated. So I'm going to show you a format in which you're going to do all of that. So the data involved should be tabulated and with their appropriate units. Now when you are measuring length, you record your length in meters, which is the SI unit, except if you are told to use a particular, what's it called, maybe you are given in centimeters and you are told to take your measurements in centimeters. Maybe you are taking potential difference, you are measuring the voltage across a particular cell, maybe 3 volts. So that unit should be there. And then we have the, what's it called, the data, like I said, should be well written down with the appropriate units. Then the graphs should be plotted if required. Well, most cases the graph is actually a representation, a pictorial representation of what you've performed in the experiment, in which we are going to compare the experimental value with the theoretical value, and then if there is any calculations, they should all be done. Don't forget, you're going to be calculating slopes if required, intercepts, and all other relevant calculations. They should be well answered, and any other discussion should be there. And then lastly, just the conclusion, the inference about the particular experiment. Oh, when I performed the Ohm's law experiment, was it in line with Ohm's law? What I actually observed experimentally, is it actually following what was taught theoretically? And then the precautions, these are some of the things you avoided, some of the things you took note of while performing your experiment. Some of the precautions, let's say you're working with okay, let me just pick, though this is not part of it, but let me just use this. Maybe you're working with stopwatch, so the proper counting of your number of oscillation should be well noted, not that maybe it should have gone over. And maybe when you're working with circuit connection, some of the precautions you need to take note of is you avoided errors such as partial contacts, such as battery drain as a result of closing the key. So some of all those things, and then all works should be done inside a workbook. Now we normally use workbook, and that's your graph. What's it called? It entails where you're going to write some of all these things you've observed, and then you're going to plot your graph. So I believe the next thing is the error analysis. What do you mean by error? Error is one of the important foundations of experimental physics, and you need to pay proper attention to it, as it can affect the required value. And some of the things we'll be doing is, how do we measure this error? We have systematic errors, which are errors that affect readings in regular and predictable manner. A very good example is heat losses in calorimeter experiments. We have zero error in voltmeter or ammeter. Some of these ones are systematic error, and they are errors that affect the readings in a regular and predictable manner. Then the second type of error that we're checking is erratic error. These are the errors that affect the reading in a regular manner, and a very good example is wrong calculation. Maybe you are trying to do some decimal calculation on your calculator, and what you are doing, you are using the wrong method or the wrong approach. Or let's assume you want to do exponential, and at the end of the day you end up putting different things. So these are some of the erratic error. And then we have random error. These are errors that occur due to the fluctuation or fluctuation in the measured data due to the precision limitation of the measurement measurement device. So let's just check if we'll be able to see some examples. So this is error estimation. We have maximum error, and we have standard error. The maximum error is the total error which a measured value could contain. And in most experimental measurements, it's very easy to estimate a maximum error. it gives the outside limit of such error. And we have standard error, and the standard error is used to determine the effects of measurement error on individual results. And then the quantity which measures the amounts of random fluctuations in a value is the standard deviation, which is the function of the standard error. And then the standard error of the mean is given by which is S equals W over N, where W is the width or the range, that is the difference between the greatest value and the least value, and then N is the number of measured values. Now let's quickly check an example. Let's quickly check an example on this error. Now this is an example. Suppose a measurement is made and the lengths measured are given 4.7, 4.6, 4.9, 4.5 and 4.8 centimeters respectively. Now you're able to calculate the error. These are the lengths that were measured. The first one was 4.7 up to 4.8 centimeters. So you are actually going to write down the now I want to calculate the true value. The true value is the total, the summation of all the lengths they were taken divided by the number of values they were taken. This is the first one, this is the second one, 2, this is the third one, fourth and fifth value. That's why we have the number towards 5. And then after doing the whole summation divided by the number of values, we got 4.7 as the true value. Now for the standard error, we said the standard error is the greatest value minus the least value divided by the number of values that were recorded. So our standard error was given by 4.5, which is the highest value that was recorded, minus the least value, which is 4.5 centimeters, divided by 5. So we have 0.1. So our total value will be recorded as which is the true value plus or minus the standard error in centimeter. And then some other things we're going to be checking is combination of errors. We have error in summation. We have this example here, error in summation. They were properly highlighted there. We have error in quotients and products. So we have this is another example. This is just an example on this simple pendulum, the period of oscillation for this simple pendulum, whereby we have to calculate the acceleration due to gravity. So we've can check through all of those, and then at the end of this particular section, you should be able to go through some of these self assessment questions, like you define errors, you explain 2 types of errors, and then types of error in measurement. And you should be able to do this. Then some of the examples are the questions are given here. So in the next video, I'll be going to some of the major things we'll be needing. So thank you and have a nice day.